Alright, so hello and welcome all of you. We are live right now. Please give me a thumbs up if you are able to hear me out. We are live right now. Alright, so welcome all of you to this incredible platform of Pradhan Academy. Okay, so today we are back again with important discussion, and today we are going to discuss the important chapter of quadratic equation, and we are going to make this chapter especially for the JEE Advance. Right, so we are basically targeting for the upcoming JEE Advance examination. And with regard to that, I'll be basically catering the need for every JEE Advanced aspirant so that I can help you out for the upcoming JEE Advanced preparation. Okay, now quadratic equation is one of the most simple chapter and yet an important chapter for your mains as well as your advanced examination. Okay, now especially if you look at advanced, there has been different types of questions that can be framed from this particular chapter itself. So having a proper knowledge on this chapter is very important and crucial. So with this idea, let's get started. So today we are going to discuss the previous year questions from the chapter of quadratic equation, and we are going to make it ready for the upcoming examination. Right. So now before you start this chapter, I would request all of you to please go through your NCERT and make short notes. Okay. Go to your NCERT as well as your NCERT exemplar and prepare short notes before you are starting for this particular chapter. Okay. So this is what we are to basically discuss in the beginning. Now there is a very good news to all of you, that is I'm going to start up basically a online batch which is basically for your upcoming JEE mains and advanced examination for 2026 and 27. In order to enroll to this particular batch, you can always contact on this particular number. Okay, the number you can find it over here. You can always contact on this number and you can enroll in the upcoming monthly batches. Okay, so we are going to start live on the online batches, and here is the price of the batches. The price of the batch is very small. Okay, it's just under 1000. Okay, it's just under 1000. So this particular batch is targeted for the 2026 and 27 students who are basically going to appear for your JEE mains and advanced examination in 2026 and 27. Okay, so if you want to get live access of this batch and you want to ask up how the batch will go up and what is the schedule of the batches, you can always contact on this particular number to get any more information on it. Okay, and the pricing of the batch is starting from 999. Okay, just 999. Right, so to get enrolled in the batches, because the seats are limited, please make sure that you enroll it today. Okay, enroll for this batch by signing on this particular number. Okay, by just signing on this number, and you can contact this number, and you can always get the access to the live online batches with this particular price. Okay, so this is basically for the upcoming JEE mains and advanced 2026 and 27. So this is going to be very crucial for the students who are going to prepare for the upcoming, who are basically in class 11th and 12th. Okay, so don't miss out this particular opportunity. This is going to be very important and useful for all of you. So with this, let's get started. So today our goal is to discuss the previous year questions of JEE mains and advanced for only at JEE advanced, especially for quadratic equations, and along with that we're also going to practice numerical type questions specially. Okay, the integer type and the numerical type questions especially for the upcoming JEE advanced examination. So with these things in mind, let's get started. So here is a very first question on your screen. Right. So please try to solve this question. Please give it a look. Please try to give it a look. Please try to solve this question. Okay. So if you try to look at this problem over here, it is talking about that there are multiple numbers which are given as a, b, and x and y are the real numbers. Right. And it is said that the given equation are following given as 3x plus 2y is equals to log of 18 to the power 5 by 4 base a, and 2x minus y is equal to log of square root of 1080 to the base b. Now looking at this question, you might be wondering that how come this kind of simple question be coming up for your JEE Advanced, right? Now before you start to solve this question, I would say you that it is nothing like JEE Advanced will always ask you difficult question. JEE Advanced basically try to ask you those questions which are very, very conceptual. Okay. So it is very important to turn on to your concepts. Okay. So if you have a good concept, if you have a good understanding about the concept, then the questions are very simple to solve. Okay. So with this note, if you try to look at this problem over here, it is said first and foremost thing, it is said that A is equal to 3 root 2 and your B is given as 1 upon 5 to the power 1 by 6 square root of 6, right? And then it is said that if your x and y are basically real numbers such that 3x plus 2y is equals to log of 18 to the power 5 by 4 base A and 2x minus y is equal to log of square root of 1080 base B, right? Now, in order to solve this question, you have to basically find out the value of x and y in order to get to this value of the 4x plus 5y expression. So let's try to simplify this question in the format so that we can simplify this out, right? So what I'm going to do over here is that I can write this particular first equation, that is 3x plus 2y, 3x plus 2y as follows, So this is can be written as 5 by 4 times of log 18, and log 18 can also be simplified as, that is, I can also write this expression as 3 root 2 whole square, 3 root 2 whole square, and then the base is also 3 root 2. So this is going to give me the solution as 5 by 2. So the first equation I have with us is basically 3x plus 2y is equal to 5 by 2. That is my first equation. And then the second equation is, given as 2x minus y is equal to natural log of square root of 1080 and base B, right? Now what is square root of 1080? I will try to simplify in terms of the, so that I can easily simplify out from the base. Okay, so the base is given as, the base, that is B, that is given as 1 up by 5 to the power 1.6 into square root of 6, right? So I have to try to establish this particular quantity in terms of this so that I can simplify it out easily, right? So in order to do that, first and foremost thing, I can write this expression as half times of log of base B 1080, right? Now I'm going to simplify it further as, I hope you're able to understand my way of solution. Okay, so please try to solve it. Please try to solve it. Yes. So I can also write this expression 1080 as follows in terms of 5 and 6, as that I can write this. And take it on the next page. I can write 1080 as 6 cube into 5. 6 cube into 5. So that is what will give me the better advantage, because I am able to simplify it out in terms of 5 and 6 as a base, right? So if I consider that particular thing, then that's log of base B and half is there, 1080 can also be given as log of and the base is basically given as, and if I just see the base, the B is given as 1 by 5 to the power 1 upon 6 into square root of 6, and that I can write it as 1 by B. I can give it as 5 to the power 1 by 6 into 6 to the power 1 by 2. That I can write as 1 upon B, right? Now if I take square root on both the sides, if I take square root on both the side, then it is going to square root of this particular quantity, and then I'll get my following result as, then from here I'll get the following result as, this particular result will be becoming equal to 6 to the power. So if I take, instead of square root, if I take whole to the power 1 upon 6, that will be much better. Okay, if I take whole to the power 1 upon 6, then I'm going to simplify it further in one step. So 1 upon 6, whole to the power 1 upon 6 will give me 6 to the power 1 by 2 and 5 to the power 1 upon 6, which is nothing but 1 upon B, right? Now, therefore, 1080 whole to the power 1 upon 2 is nothing but 1 upon B whole to the power 3, right? So therefore, if I take natural log of b, log of 1080 and square root of that to the base b is given as log of 1 by b whole cube base b, and that is going to become as equals to minus of 3. So therefore the second equation over here we have it as 2x minus y is equal to minus of 3, right? So this is my second equation. So once I have both the equations, then I am able to simplify it further. I am able to easily get the values of x and y. So on solving the system of equation, the first equation, second equation, I get the following values of x and y as, so x will turn out to be minus of 1 upon 2, and y will turn out to be 2, right? So therefore, from this particular result, I get the values of x and y, right? So now once I get the value of x and y, therefore you have to basically find out the value of 4x plus 5 times of y, which is nothing but is equals to minus 2 plus of 10, and that is going to be equal to 8. Right? So this is basically going to give me the correct answer to the particular result. That is, ultimately we are going to get the answer of this 4x plus 5y is basically equals to 8. Right? So the numerical answer to this question is going to be equal to 8. I hope you are getting the same answer. Bro, is it sufficient for advance? Yes. Yes, bro. Niga, bro. Yes, it is sufficient for advance. The great Niga. First of all, complete it, okay? Then you will talk about is sufficient or not, okay? Try to finish it. Try to complete it thoroughly. And then whatever types of question will come up, you can be able to solve it, okay? Is this clear to everyone? Yes, no? Is this thing clear to all of you? Are you all getting the answer as 8? Are all of you getting the answer as 8? Do let me know if you have any confusion over here. Okay, I'll try to help you out. If you have any confusion, you can post that in the live chat. Okay. If you have any confusion, you can post that in the live chat. I will try to help you out with your confusion. Is this part clear to all of you? Is this part clear to all of you? Are all of you getting the same answer as option A, 8? Are you all getting the answer as answer as 8? Yes, no? Okay. So I hope this particular part is clear to all of you. I hope you were able to understand the solution. Okay. So if this part is clear and you have got the answer as 8, then let's move to the next problem. Let's try to solve the next problem. So the next problem we have with us is again a problem which is involving the concepts of logarithm, right? So if we look at the question over here, what we see, we have x to the power 16 log x base 5 whole cube minus 68 log x base 5, and this particular thing is equals to 5 to the power minus 16, right? Now we have to solve for the real values of x, right? So product of all positive real values of x satisfying the equation as follows, right? So from this equation, I have to find it out the solution for the x, right? Now how will I do it? How will I solve for this? Any ideas? Any idea? How will I solve for this? Please try to give it a look. Please try to give it a look and try to think what should be the possible solution. Try to give it a look. How will you solve it? Tell me. Any possible solution? Okay, so if you look at this given equation over here, what you see that there is one particular term which is repeating, right? So whenever this kind of terms are present in the exponent and it is repeating, it is better advantageous to take this particular term as common or as some another variable. So if I assume log x base 5 as some variable t, then in this case, I am able to simplify this particular solution as or equation as follows. Or what else I can do that is that I can take log on both the sides. If I take log base 5 on both the sides, then this particular equation is going to become equals to minus 16, and that is going to become equal to 16 times of log base 5x whole cube minus 68 times of log x base 5, and that particular thing is equals to minus of 16, right? Now if I assume this log x base 5 as t, then this particular part is going to simplify out as 16 t to the power 4 minus 68 t square plus of 16 is equal to 0, right? Because there is one more, I forgot to write over here, because there will be one more. So when you decompose this, there is going to be one more log base 5x, right? That is multiplied to it. Okay. Or should I write it in the next equation, because that is taking log on both the side. So here there is one more log base 5. Okay, that is multiplied. Okay, don't forget this part. Right. So now this is going to be my required quadratic equation or required biquadratic equation over here. The solution of t's are basically solution for this required values of x, right? So how am I going to solve this? If I take 4 common out of here, it is going to give me 4t to the power 4 minus 16t square minus 17t square 17t square plus 4 is equal to 0. Now which I can simply factorize out as 4t square minus of 1 multiplied with t square minus of 4 equals to 0. So this will give me the two required values of t as it is going to be plus minus 2 or it is going to be plus minus 1 upon 2, right? So now we have to look for all the possible values of or real values of x. So from this particular result, once we get the value of t, log x base 5 is equals to plus minus 2 or is equals to plus minus 1 by 2, right? So from this we'll get the values of x as follows. 5 to the power 1 by 2 or 5 to the power minus of 1 by 2, or I can have it as 5 square, or I can have it as 5 to the power minus 2, right? So these are the all following possible values of x I can have it from this particular case, right? So on solution of this t, from there I can equate it with the log of x over here to get the all possible solution of x. Now we have to basically find out what is the product of all the possible solutions. So if I take the product of all the possible solutions of x, right, so that is going to give me, so this part and this part are going to cancel out 1, and this part and this part are going to cancel out as 1, and therefore the product is going to be ultimately equal to unity, or that is 1, right? So ultimately the product of all the possible real roots of this particular equation or satisfying the equation, I will have it as answer as 1. Is this part clear to all of you? So the numeric answer to this particular question is going to be simply equal to 1. Is this part clear to all of you? Is this solution clear to all of you? So ultimately the answer is going to be 1. Are you all getting the same answer as option as 1? Do let me know in the live chat. Are all of you getting the same answer? Yes, no, anything? Are you all getting the same answer as option 1? Do let me know if you have any questions. Okay, I'm waiting for a live chat. Do let me know if you have any questions. Okay, so from this result, you're going to have the possible solutions of x as follows, and the product of all the possible values of real values of x is going to give you equal to 1. Okay, so I am assuming this particular part is clear to all of you, and with this part, let's move to the next problem. With this part, let's move to the next problem. Okay, so the next problem we have with us is another very interesting problem where the equation is not straightforward given, whereas it has involved multiple different functions. Okay, so here we see a modulus function over here. So from that modulus function, we have to basically simplify it out, and in order to get a solution, we have to simplify the equation for the different ranges. Okay, so in this types of questions, whenever this types of question will come up, generally for your exam, it is very important to make cases. Okay, so if I try to look at this problem over here, first and foremost thing, it is said that your x is basically belongs to real number. Where x is basically belongs to real number, and it is said that we have to find out the number of real roots of the following equation, right? So the equation given over here is 3x square minus 4 times of mod of x square minus 1 plus x minus 1 is equals to 0, right? So we have this particular equation over here, and we have to find out all the real roots for this particular equation. So let us see how we do it. The first thing I would suggest all of you to do is over here is that since I have this mod and this quadratic part over here, so if I factorize this side, it can be factorized as x minus 1 into x plus 1 and mod of it, right, plus x minus 1. Now if you look at the graph of this x minus 1 function, you will find it out that this particular function has in roots as 1 and minus of 1. In between 1 and minus 1 it is negative, and all the other parts it is positive, right? So what I will do over here, I will try to make some cases. I'll make some first case when my x is basically greater than 1. I'll make three different cases of three different intervals of x, based on which I will try to keep my following results. Okay, so first of all, let me make a case where the x is basically lying in between 1 and minus 1, where the x is basically lying in between 1 and minus 1. So in that case, the mod of this x square minus 1 is going to open up in negative. So that is going to be equal to minus of 4 times of minus of x square plus of 1 plus x minus 1 is equal to 0. Now from this particular equation, we will have it as 3x square plus 4x square minus 4 plus x minus 1 is equal to 0. And therefore, I can simplify it as 7x square plus x minus 5 is equal to 0. And on solving, we get one quadratic equation, right? Now, the roots of the quadratic equation, that is x is equals to minus 1 plus or minus square root of 1 plus 40 divided by 140 it will be divided by 2 times of 7, that is 14, right? So this is going to be the solutions of x for this case, right? But unfortunately, we need the solution of x which also satisfying this particular quantity, that is x should satisfy between minus 1 to 1. Hence, but if you look at the solution over here, it is basically square root of 140 plus minus square root of 140 minus 1 divided by 14. Now, in this case, both of the values are going to lie in between minus 1 to 1. Hence, both the values of x are the acceptable solution, right? Therefore, both the values of x are acceptable solutions. So, from this particular case, we will have two real roots. We will have two real roots, right? And the next case, what we can make one more case is as follows. We can put the x values when magnitude of x is greater than 1. So in this case also, when x is greater than 1, in this case x will lie between minus 1 to 1 union 1 to infinity, right? So in this case also, I will be able to simplify the equation as 3x square minus 4 times of x square minus 1 plus x minus 1 is equal to 0. Now on solving, I will get the equation as x square minus x minus 3 is equal to 0. Therefore, x is equals to 1 plus minus square root of 13 divided by 2. Now, in this case also, you will see that both the values of x are also lying in between, lying in this particular interval. Hence, here also I will have two real roots. So, in this case also I will have two real roots. So, therefore, the total number of real roots for this particular equation will be equals to 4. Therefore, I will have four real roots for this particular question. So I will have 4 different real roots. Okay. So therefore, the answer to this particular question is going to be option number. Is going to be answer as, or numeric value is going to be equal to 4. Okay. Are you all getting the same answer? Yes, Almond. All of them are PYQs. Okay. Yes, I have taken up all of the questions from the previous year questions only, so as to give you an idea how the different types of questions are being asked. Okay, so that you also get an understanding even how to solve the question in the actual examination. Okay, since you don't have much more time, so if you want to look up preparation for the revision, especially for revision, or you are done with your mains and advance with the preparation, then this previous year question session is going to be very, very useful. Okay, because through this previous year question session, I'm going to try to revise the concepts, and with the concept, we are also going to solve the question along with that, right? So that is very, very useful and helpful for all of our aspirants. Okay, is this part clear to all of you? Is this part clear to all of you? Do let me know if you have any questions. And if you're watching the lecture after the live class is over, you can always put the question in the live chat. After the live chat is over, you can always put your question in the live comments, okay? Or maybe the comment sections. Okay, I'll be very happy to answer your questions from the comment box. Okay, don't feel hesitated to ask your questions. Okay, do definitely ask me any question if you feel any difficulty anywhere. Okay, because if you still keep the difficulty, if you still keep the doubt that I don't even know this particular part or how to solve this particular part, then it might be very difficult for you when you're actually solving the paper in the actual examination. So please don't keep any minute of a doubt in your mind. Okay, try to clear the doubt as fast as possible. And also, if you like this kinds of video support and you want to get much more, and you want to get live doubt clearance, and you want to get one-to-one mentorship, in that particular case also, you can always contact me on the number that is given in the description box. Okay, so please find the description box of this particular channel, and in that you will find out all the necessary details to contact me on that particular contact number. Okay, in case you want to enroll for the upcoming mains and advanced batch for 2026, you can always contact the number and get connected with the batch access. Is this part clear to all of you? Is this part clear to all of you? Right? Okay, so if this part is clear, let's try to move to the next problem. And the next problem I have is a very interesting problem. It is said that following A, B, and C belongs to the non-zero real numbers. Okay, so they are real number, but they are not zero, such that square root of 3a times of cos of x plus 2b sine of x plus 2b sine of x is equal to c for x basically lying between minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2. And it is said that this particular equation has two distinct real roots. The roots are given as alpha and beta, such that the summation of the roots is given as pi upon 3. The summation of the roots is given as pi upon 3. Now, with this particular information, I have to basically find it out what is the ratio of b upon a. So with this particular information, I have to find it out what is the ratio of b upon a. Right. So if you look at this problem over here, that's alpha plus beta. So if you recall, the sum of the roots of any quadratic equation is equals to minus. So if I have any general quadratic equation like ax square plus bx plus c is equal to 0, and the roots are alpha and beta, so in this case, if I take the summation of the root, it is basically equals to minus b upon a. Right. So similarly, if I get the summation of root over here, I will get the summation of roots as follows, right? That is given as pi by 3. But since this is not a quadratic equation, so this is not that simple to solve, right? But what you can do is that, now since the summation root is given as pi upon 3, from here what you can do is that you can substitute beta as pi upon 3 minus alpha, right? So if beta is a solution, so if alpha is the solution of this particular equation, then beta is also the solution, right? So what I'm going to do over here is that I'm trying to take help of the quadratic equations. Okay, so I'm going to try to take the help of quadratic equation. So if I satisfy both the solution over here, then I will have one set of equation as 3 square root of 3a cos alpha plus 2b sine alpha 2b sine alpha is equal to c. That is my first equation. And the second equation will be root 3a cos beta plus 2 times of b, 2 times of b sin beta is equals to c. Now this is the first equation, this is the second equation. Now if I try to subtract the second equation from the first one, then I will get the solution as root 3a times of so okay, so let me do the opposite one, okay, so that you can feel much easier. So I am subtracting 1 from a, 1 from 2, okay. So 1 from 2, in this case I will get it at 3 root 3a cos of alpha minus cos of beta plus 2 times of b into sine of alpha minus sine of beta is equal to 0, is equal to 0. So if I solve by this particular form by using the standard equation, so that is going to become equal to root 3 times of a minus 2 times of sine alpha plus beta by 2 into sine alpha minus beta by 2, and the second part I will have it as 2 times of 2 times of sine of alpha minus beta by 2 into cos of alpha plus beta by 2, right, and that is basically equals to 0, okay. Very sorry, this is plus of 2 times of b, okay, 2b is also there, right. So then if we solve it by using the by given values of alpha plus beta is equal to pi by 3, then this result is going to simplify it as root 3a sine of alpha plus beta by 2 is equals to 2b times of cos of alpha plus beta by 2, because this sine of alpha minus beta by 2 and this sine of alpha minus beta by 2 can get cancelled out because it's not going to be equal to 0. So I can therefore simply cancel out, and therefore from this result I will have tan of alpha by beta by 2 is equals to 2b upon root 3a, and therefore from this result alpha plus beta is basically given as pi upon 3. Therefore tan of pi upon 6 is equals to 2 by root 3 b upon a, and that is going to simplify it as follows. So from this I am going to simplify it as and therefore b upon a is going to be equal to 1 upon 2. Therefore b upon a is going to be equal to 1 upon 2, right. So therefore the numeric answer to this particular question is going to be 0.5, is going to be equal to 0.5. That is going to be a numeric answer to this particular question. So this is quite interesting, that actually helped you to try to use the case of the quadratic understanding as well as to use the trigonometric equations, okay, as well as to use the trigonometric ratios or identities. Is this part clear to all of you? Do let me know if you have any questions. Okay. Is this part clear to all of you? Okay. So do let me know if you have any questions. If you still feel there is a difficulty, or if you have a doubt anywhere, we can try to solve this question. And let me know what is the answer you are getting. Are you all getting the answer as 0.5? Please comment in the live chat. Shikhar Gupta, quadratic equation is one of the easiest topic in class 11 and 12 syllabus. कुछ धमाधर topic पढ़ाया करो. See, quadratic equation is easy. That's why I have taken up, because it is also very important for and crucial for the JEE advance. Okay, so thinking of the priority and the importance of the chapter, I am taking up this particular topic. ठीक है Shikhar Gupta. Hemang Saini, sir, I have a doubt. Tell me what is your doubt. Hemang Saini, tell me what is your doubt. Please tell me your doubt, Hemang Saini. Okay, so are you all getting the same answer as 0.5? Shikhar Gupta, did you solve this question? सर मेरा आंसर 2 आ रहा है. एक बार फिर से ट्राई करो. मैंने कैसे किया, एक बार ट्राई करो फिर से करने का. Okay. See over here, if I just put the alpha beta, it will satisfy the equation, right? Now what I'm doing is that I'm subtracting 1 from 2, and in that case I will get this result as follows, right? सर आंसर नहीं आ रहा है, 2 आ रहा है. नहीं. See, check it again. Tan of pi by 6, pi by 6. Can you repeat the last part? Yes, I am repeating. See, from this particular equation, once I am solving this equation, I get tan of alpha plus beta by 2 is equals to tan of alpha plus beta by 2 is equals to 2b upon root 3a is equal to 2b upon root 3a, right? Then tan of now alpha plus beta is basically given as pi upon 3. So tan of alpha plus beta by 2 will be basically equal to tan of pi upon 6, and tan of pi upon 6 is basically 1 upon square root 3, right? So therefore this root 3 and this root 3 will cancel. So b upon a is equals to 1 upon 2. So b upon a is equals to 1 upon 2. ये वाला जो 2 है ना, वो इधर चला के 1 upon 2 हो जाएगा, right? So therefore b upon a is equal to 1 upon 2, that is going to be 0.5, because in the question it is asked for to get the value of b upon a, right? Not a upon b. So if it was asked for a upon b, then the answer would have been 2. Is this clear? Hemang Saini, is this part clear? Is this clear to all of you? Thanks sir, आंसर आ गया, सिली मिस्टेक थी. देखो देखो, सिली मिस्टेक्स मत करना, ठीक है? Take your time, be patient. Okay, whenever you are solving the question for mains and advanced, it is very important to be patient enough. Okay. So with these questions, we come to almost the end of the particular session. Okay. So now there are some of the important questions that I have left out as homework. Okay. Now please try to solve this question as homework. Okay. And let me know the answer you're getting in the live chat or maybe in the comment section. Okay. So please take a screenshot of this question. Now these questions are very, very interesting. If we look at these problems over here, they're not very traditional. So looking at the question, you might not get the right answer or the feel of the answer, right? But you have to be patient with these questions and try to understand what the type question is being asked over here, right? So if you look at the problem over here, this kind of a recurring relation over here, right? So maybe you can give it a try, and if you're not still not getting the answer, you can always ask me in the next upcoming session. Okay, I will try to answer your question in the next upcoming class. Okay, so this is one of your homework question for the upcoming part. Okay, please take it homework and please solve it. Take a screenshot of this problem. Take a screenshot of this problem and please solve it. Right. Okay, and I have some more problems also with me. Now this is one more important and interesting problem. So it is basically talking about a biquadratic equation, and from this biquadratic equation, we will basically find out the number of distinct real roots. Right. So this is very interesting, and in order to solve this question, you might be needing to take help of calculus. Okay, so in order to solve this question, you might require the need of calculus. Okay, so please try to make sure you remember the important theories behind it in order to solve this. Okay, maybe the Rolle's theorem will be very useful in solving this case of questions. Okay, where you don't have to solve for the actual values of the roots, but you have to get the number of distinct roots. Okay, so with these two homework problems, I would like all of you to please give it a try and please let me know the answer in the comment section. Okay, so with this part, I basically conclude the session over here, right? So if you still have any question, you can always put that in the comment section, and with this I would like to conclude